this area of protocols can be very dry if you do not try by yourself, and it is very exciting if you try things by yourself. Okay. So let me take you to an exciting area, an exciting website which you can try, and that brings me to this website. Okay. This is what is known as the website related to ThinkSpeak. Okay. This ThinkSpeak has what are known as public channels from where you can download data which was uploaded by different MQTT clients. Several of them gathered the environment data and put it up on a free cloud based broker. Okay. And now the data is available on the broker. You can connect to that broker and download the data and build your own application. Remember what I mentioned about the blinds, window and blinds application, how new applications can be built. Quite like that, you can build your own applications. What are those free channels, public channels? You have San Diego some information, okay. Then you have air sensor data, you have some other some channels, then you can look up, there is a weather climate node, then there is a weather station data and so on and so forth, air quality data, carbon dioxide data, okay, and so on. So you can download this data and build your own applications live. You can connect to the internet to thinkspeak.com channels public and you can actually download. So you click on this let us say this website, you can see that live data is actually available to you. Okay, this is in some language which perhaps difficult for you to interpret, it must be Spanish. So anyway, so this information is available. Okay. Suppose you want to download this data, you click on this button, you can get it in CSV, XML, JSON, right. CSV is comma delimited file, XML and JSON are machine readable formats which you can directly build, you can take it into another machine. You can write a program for one machine to suck this data and consume this data without humans. If you do CSV, you are stuck, you have to download, you have to open Excel or any one of these spreadsheet applications and you can plot it, that is for human consumption. But supposing you want sensors to consume this data, because you said IoT paradigm is sensor talking to another sensor, data traffic is generated not by humans but from machines, for machines, from machines to for machines. So how will you do that? You put it either in XML or JSON, so machine readable formats are available. So machines will consume this data and whatever application you can build it that way. So folks, what is the lesson that you learn? The lesson you learned here is that if you want to make machines consume data, you must have a particular format in which you can download and get machines to download data automatically and get the data to be consumed automatically. Amazing. So you can try this on your own. Now what we can do is, see, this is something you can build free, you do not need any account. Okay. For example, you want to build, you can do this. You can also do a few things for free, so you should try that. Okay. For example, you can create some free channels and you can use those free channels. So this website actually is supported by MathWorks, which is known for the MATLAB software, and this whole thing is actually set up by them for academic purposes, for educational purposes. Students, if they have a MathWorks account, can freely use this account and start learning a little bit about IoT and how MATLAB simulations can be uploaded to cloud and how you can build major applications and so on. Anyway, so it is from MathWorks. I will come to this basics, but you can see that you can create ThinkSpeak MQTT device. In other words, suppose you have a sensor, IoT node sensor, okay, which runs MQTT client, and I gave you the name PAHO. You can run on a small embedded node, you can run MQTT client PAHO, and even including nodes like If you are talking of slightly high computing, you can talk about Raspberry Pi. Otherwise, you can also talk about small embedded controller boards which have the capability to talk to the internet directly or pass the data to a Wi-Fi Bluetooth router, and that router in turn getting it data to the MQTT broker. So, please note ThingSpeak is a cloud service, and what does it support on the cloud? So, I will put it like this somewhere on the internet, and here inside this internet somewhere here is this ThingSpeak broker, but we will start using the word server. So, let us call it MQTT server, okay, SCRVER. So, let me put it properly. And you are sitting here somewhere in your home, office, lab, wherever, and you have your sensor node which supports IEEE 802.15.4, or it can support, this is one type of wireless protocol, another one is Bluetooth low energy, the third one is Wi-Fi, any one of them it supports. Your lab has a internet router which is connected to the internet, okay. Now your node is gathering some data, let us say movement data, or it is collecting outdoor, go back to the same example, let us say it is collecting the outdoor light data, not insolation, I would say light, outdoor light. So we said we will have outdoor light, outdoor, indoor and presence, human presence, okay, these three. So you can keep uploading the outdoor light information to your wireless router, which in turn puts it up on the internet and gets uploaded on one channel which you have created. So I will say custom channel, and on this custom channel you are uploading outdoor, indoor and presence data, okay. And now this data, once it is sitting there, your lab home blind has to consume this data because it has to open the blind automatically. Remember we said two possibilities exist in that application. One is the blind system has a motor actuator which has a mechanism to move the blind up and down, it has a sensor node and the algorithm is running right on the sensor node. This is one way, that is what we said in the last class, but why should it be that way? Someone asked in your set of questions also that why can't I do all the compute on the cloud and keep my sensor systems simple, sense and send, why not do all the compute on the cloud? Sure, that is another possibility, okay. You can send everything to the cloud and let the cloud compute the amount of opening of the blind and make it available to the actuator system, that is another possibility. But there was also another question by one of you which said, why do I need internet to enable IoT for my home lab? Someone said that also, one of you said, why do I need internet to enable these applications? That is another possibility, you do not need internet, get your sensor node to transmit the data, let your actuator node do all the computation, both are possible. Anyway, we are just discussing protocol, so I thought it is important for you to connect everything that we have done in the previous class. So you can do this, put it onto your custom channel and get the other sensor, blind sensor, to download this data. Now you have to follow MQTT, which means there is a certain protocol, there is a certain way to upload the data, there is a certain way to establish a connection. So one is establish connection and there is a certain way to send the data and there is a certain way to receive the data. The way to receive the data is you do a subscribe. The way to send the data is publish. The way to establish a connection is connect. These are all part of the protocol. Do I need to know a lot about the protocol? Yes, you must know the protocol in detail. Where do I find this information? Well folks, there is information out there which is quite easy for you. I will point you to that. Here you are. Connect. Client requests a connection to a server, it is right there. Read this in detail, you will understand how to connect. Now where is the demo? We are still talking about so much of the protocol, where is the demo? Yes, demo will come provided you understand the protocol well. So let me shift now back to the demo. So let me draw your attention to this little box here which has several components. Maybe I should tilt little bit in this direction so that it will help you to look up the different components. What this has are two identical units on either side, and it is doing air quality check from automobiles. One of them is taking from automobiles and the other is taking from ambient, right. This is from the automobile part, I think this is from the air, from the ambient, and this is from the automobile part, and this will take it from the exhaust directly, and this will take from the ambient systems. These sensors here acquire the data by this computer here. This is a Raspberry Pi, this Raspberry Pi computer here, and this in turn collects the data and uploads using a 4G modem, 3G or a 4G modem, and in order to know where, because it is a mobile unit, since you want to know where this unit and where that measurement was, you need a GPS system. So the GPS is here. So you can see this is the GPS, this is the 3G 4G modem, and these are some massive batteries for powering this system. The hardware that I showed you essentially has monitoring all these parameters. You can see that we are monitoring ambient temperature, we are monitoring ambient humidity, we are monitoring ambient particulate matter 2.5 PM10, ambient nitrogen dioxide is also measured here, ambient nitric oxide to the right, what you see here is nitric oxide, what you see here is ambient nitrogen dioxide, and let us see what else do you measure. You measure ambient ozone, you measure ambient ammonia, and the location is indicated here, as you can see nicely, it is indicating because we have a GPS module inside this system. You see that it is now actually being monitored in real time. If I put my mouse on this, it is actually measuring the value, and if I put it on this, it is actually putting the value. Now that we are showing you a live demonstration, live of this data that is coming in, can we invoke some way by which we increase the particulate matter and see whether that corresponding you do something at the inlet and see if you can increase the particulate matter, whether our sensor is sensitive enough to show a slight rise. So you can see he has taken some waste, automobile waste, which perhaps has all the ingredients of increasing the particulate matter, and then he just gives it as an input inside the system, okay, and the air is absorbed because there is a pump here which will absorb the air. And now let us see what happens. Let us turn our attention to the screen. You see quickly that there is a rise in the particulate matter, there is a rise in the particulate matter. So you can see that it has risen quite significantly actually. It has the particulate matter 2.5 has gone quite high, as high even close to 200 micrograms per meter cube, and the same with PM10, which has gone up to 200 micrograms per meter cube. And why has it come down? Because he has stopped, we have stopped feeding polluted air by adding any pollutants to the air that is being sucked by the system here. We can do another demonstration for ammonia as well. So let us now try an ammonia experiment. Look at this live data coming about ammonia. You can see that I brought the bottle close to the device and then it had a chute. Now our project staff Abhishek has moved away and then the value has come down. I will request him to come closer, you will see a spike again. So let us keep watching this. So let us see, let us put it closer, now it is closer, it should start sensing the ammonia. Now data, yeah, you can see that he has brought that bottle. So there is air mixed with ammonia, you can see that there is a rise, right. The air sample is taken, measured by the ammonia sensor and then there is a chute. Okay, now he has gone away, we have gone away from the system. So it should now drop back into some value. Again here we are measuring in terms of concentration in parts per million ppm. This is one way of measuring, you can see it has come down and now the sensor says okay, the air measuring is now replaced with fresh air and that fresh air does not have any more ammonia. Okay. Now see what is written here, very simple to read actually. The way to start uploading data to the cloud is first is to try from an MQTT client like PAHO to establish a connect. I want to know more about connect, you know what to do, open this here, you come to connect, right. You want to know more about connect flags, it is right here, okay. How to clean session, how to start with a clean session, how to start resuming from an existing session. You make it 0 during connect, if you make a flag as 0 then it will resume, if you make the flag 1 it will start a new session, that is written here very clearly. Where is it? Right here, you can see that there is a nice definition of these two here. Line number 426 talks about 0, line number 434 talks about 1. Very simple folks, QoS 1 2 we have already discussed, it is out there. Okay, we will come to the remaining flags as we go along, but what is important is this connect and not to lose track of what this guy is actually telling us. So you know all about connect. If you send a connect you will get a CONNAC, you will get a connection establishment from the broker. Remember this broker is sitting on the ThingSpeak cloud. Remember this is your Windows blind client, okay. You are putting everything onto the cloud here. There is a certain API support from the ThingSpeak broker which you should know very well. Only based on that you can actually write data to the cloud system on the channel that you have created, okay. Then after you do that then you start publishing your outdoor light data, indoor light data, so on and so forth, you can start pushing it here. And that is exactly what he has spoken about in MQTT publish. Now how does your window blind motor controller get the data is the next question. How it does is very simple. It also connects to the cloud, connect, CONNAC, then it says I am subscribing to 3 pieces of information. One piece is related to outdoor light, other piece of information is indoor light, the other piece of information is presence or absence of humans. So it will say I am going to subscribe like that, please give me an acknowledgement whether you have received my subscription, which is sub back, and then once it receives a sub back it starts getting the information as uploaded by the sensors, which was done in this step. It is as simple as that, and that is described clearly here. Now I mentioned to you that you can create MQTT devices, you can see that this is the way by which it is you can create the device, and it will, this website will generate a code which you can copy and paste it into your PAHO client and then start uploading the data. Let us shift to that and then also show you that specific part of where exactly that this code that is generated actually appears in your PAHO client. So let us see, there you are, this is the code. Let us first see the code that is generated. You see the one that is highlighted by Vasant clearly indicates that this is the code that was generated by the at the time when you added the device. Okay. Then there is the standard API provided by ThingSpeak. One such example can also be shown, which is related to this particular thing. For example, in what format you should upload is actually mentioned here. Client.publish air quality json.dumps payload, you write like this, you put it in this format, URL open, you open the URL, you do a client publish, that means you are able to upload the data onto the cloud, on the ThingSpeak cloud. So it is as simple as that. You need to understand the API well and then start using the API in order to create your own quick application. Please, I encourage you to start using this ThingSpeak as a first step to in order to start using and learning how to use this basic system. Okay. Then there are lots of stuff related to publish and subscribe to a ThingSpeak channel using secure MQTT, publish and channel to a channel using desktop MQTT client. Just click on this, you will get a topic, it will tell you how to do it. Okay. This example shows you a desktop and all that. Try simple things first folks before you complicate anything else, right, and read this particular aspect of ThingSpeak well, so that you will be able to practice MQTT protocol extremely well. Okay, this is very important. Now the ThingSpeak also encourages you to look at some standard boards, and one such standard board appears to be the particle photon board. So you can use this particle photon board, he gives you some standard code which you can take and integrate into your system. So let us read this. This example shows how a particle photon board, how to use a particle photon board to subscribe to a channel updates from some topic called cheer lights. Okay, I will simply use the word, replace channel with the word topic. The program reads a color from the channel, from the topic, and displays it using built-in LED on the photon board. You can subscribe to the channel feed or directly to the color field on the cheer lights channel as shown in the example. So you download this code, run it, your photon board will has LEDs and you can play with the LEDs on the photon board. Essentially it is, this is the code you can put up on the MQTT broker side, and you will see your LEDs dancing as and when the whole system comes up. So I would strongly encourage you to look up this website and start using them and understand MQTT as much as required, and also its nuances. Okay, very important. See, if you go to MQTT Essentials, this website, it will tell you a lot about introducing the MQTT protocol. Okay, what is it you need to know about MQTT? This is written very well, and there is so much to learn from this whole system. And of course HiveMQ has published many articles, and they actually tell you why you should shift to from 3.1.1 to MQTT version 5. Okay, and they will tell you why that is an important thing. A lot of videos are out there, please do read up those videos, you will understand the protocol extremely well. I have to teach you the protocol in a little more detail. This is as far as building applications are concerned, quick building of the applications. Some little bit you should know about the theory, you should know about the protocol, its limitations, what are the things it does from low power, correct. You can have you need low power, isn't it, because you need 10-year lifetime. How can you use this protocol for 10-year lifetime? What happens if the battery is draining fast? How can nodes come to know about it? Those issues will come up as we start putting IoT nodes into real practice. Fine. Protocol support is there, but how do you exploit that support if you do not use the hardware properly? That is also an important thing, and we will get into that detail right away now. So let me open the best possible resource for MQTT I mentioned to you is the standard. These are all the possible QTT control packet types. Connect, connectac, publish we already know, pubback is there, received is there, pub release is there, pub comp is there, and so on. There are small differences between each one of these and their requirements. Based on the QoS level, you would be using all these additional control packets. Okay. So, if you use the highest level, which is QoS 0, 1, 2, right, the third is the highest level, QoS 0, QoS 1 and QoS 2, which is exactly once, then pub comp also will come into picture, okay, because this is all about assured delivery, as you can see here. Then there is subscribe, there is sub-ACK, unsubscribe. I do not want this topic anymore, so unsubscribe. You want to check if your client is alive or not, use ping. If you want to disconnect the client from the server, use disconnect and reserve. These are the main set of commands. Then there is, I mentioned to you about flags, know them in great detail. They are all part of the header, which is an important thing, it is part of the fixed header, and understand how these flags are used. Now let us get into little more detail. It is a little dry, but you should know. Okay. Look at these 4 bits, 3, 2, 1, 0. Okay. Here if you take publish message, how you should use these flags is mentioned. In connect you do not need this bit, they are all set to 0, but only when you are publishing. Question is why, is not it? You are telling the broker to do something, to accept this message in a particular way, that is why you need it in the publish. So what is dupe with a superscript of 1? You can look up that in a little more detail to understand. It is written here. It says duplicate delivery of publish control packet, QoS2 publish quality of service, retain 3 publish retain flag. Okay. You are setting these 3 flags, these are 1 bit flags, you are setting them. See, essentially you are saying that I will support or not support data packet duplicates. Okay. You are setting a QoS field in these systems. 1 bit is not sufficient for QoS because you have QoS 0, 1, 2, which means you need minimum 2 bits, and you are actually enabling dupe, means you are saying that I have already sent once, I am sending again. That means I have you put that flag 1, then the receiver will know, oh I see the packet was sent earlier, but it is being sent again, and that is why it comes in the publish message. Retain is interesting. What retain says is, if I publish to my broker, either the ThinkSpeak broker or my home lab broker without using internet, please keep the message with you, retain the message with you. Then if you retain it with you, clients may come with subscriptions later in that time you can publish to them when they join. It is not necessary that subscribers and publishers should be on at the same time. That is the beauty of MQTT. The sender and the receiver are disconnected. Okay. I can publish today night and go to sleep and do what I like. You can wake up in the morning tomorrow, your node can wake up in the morning tomorrow and get the data provided it was retained on the broker. That is the key point. So such things have to be thought of. So it is a very important requirement for building MQTT apps. Now to understand that you should know about it well. So we should spend at least a little more time on these important flags. So let me go to another important setting, and that setting is related to WLL flag. Now where does the WLL flag come? WLL flag should also come in somewhere here. You see, it is here, it is in the connect. When you are doing a connection, not in the publish, it is publish we already discussed, it is about the data. What are the flags in the publish? We know already, but when you are connecting to the server, you are using the very first protocol, which is a command is called the connect. There will is there. Now we will see what is this will. Will retain is there, will flag is there, and how do you do this will retain, and what is will at all in the first place is the question, right. See folks, IoT nodes get the philosophy correct. In IoT you are driving it with energy harvesting, you are driving the sensor node with battery driven systems. You do not know when the battery goes down, you can't be planning. The protocol supports that part which says even if you go down, can you not send that last message saying that I am going away, this is my last sensor data, and request the broker to say I am giving you this last message, serve it to whoever asks, comes with it with for this topic, the topic which I published, there must be subscribers, give them that message. Beauty, right. Think about the blind example. The outdoor sensor ran out of battery, ran completely out of battery. It has got the outdoor data, last sample it could get. What it did, it just said, it did a connect, ran this flag as 1 and said this is the WLL and please retain this. Now the broker knows, oh, this guy has put a WLL flag, which means this guy may not come back and give a periodic update. He is not going to give a periodic update, it put it in WLL already. Now the applications which are built around the outdoor light data are asking for the data to the broker. So give me that data, give me the data. Broker says, look, I am giving up because my sensor node has given up. He has told me this is the last piece of data and this is the last piece he has given me. I am giving you this information, date and time and outdoor light data, and pushed it to the application that has requested. So it does that. So applications which are building says, oh, I see, the last update was 3 hours back or 2 hours back or whatever, and now I have to plan my strategy because I do not have further updates, I do not have further updates. So you see now it is all integrated into the protocol, this is the beauty of the protocol. So you should use that protocol feature, and that feature comes from WLL, and that is what I am trying to show you here. Retained messages do not form part of the session state in the server and they must not be deleted when the session ends. See the beauty, retained messages do not form part of the session state in the server, they must not be deleted when the session ends, do not keep that message, okay. So what is WLL? WLL says if the will flag is set to 1, this indicates that if the connect request is accepted, a will message must be stored on the server and associated with the network connection. The will message must be published when the network connection is subsequently closed unless the will message has been deleted by the server on the receipt of a disconnect packet. So clearly he has given, unless the guy who published made a disconnect, you should not even delete it, you must keep serving, the server has to keep serving it to whoever connects to it and asks for the data, that is the point, okay. Condition under which if you have that flag 0, what should follow, what should not follow. If will flag is set to 1, what should follow and what should not follow is mentioned clearly. In other words, will flag equal to 1, something should follow. If will flag is set to 0, something should not follow, that is mentioned clearly. How will you learn all this? You learn all this through the protocol only, you learn all this through this superly good standard document. So please spend time reading this document. What is the QoS level for the will? That is also the same 3, 0, 1 and 2, right. So, all this you can specify. Will retain, I mentioned to you already about the will retain. If the will flag is set to 0, will retain must be set to 0, you can't have something following it and so on. So, please read this in great detail, you will understand the whole thing. Supposing broker wants to check if the client is free or not free, alive or not alive, it can use this ping request and can also get a ping response back, right, it can get this. So, it is also there. So, there you are folks, so many nice things about this protocol which you can use, right. Please do spend the time reading this protocol in detail, which is so beautifully written. Every command is mentioned so clearly, what should connect ACK contain, okay, and what should be maintained, what should be present in session, all that is mentioned here so beautifully. So, you can see this is publish, I mentioned to you about publish having dupe, okay. Dupe is set to 0, it indicates that this is the first occasion the client and the server has attempted to send the publish packet. If you have set dupe to 1, what does it mean? That means it was already sent once. So, you have put the flag to 1, simple as that, okay. Retain, retain is discussed in so great detail. So, you can see here the retain flag set to 1 in a publish packet, that means this is about data, right. Remember the will is in the connect, whereas the retain is there in the publish. So, when you say will and that retain, there you are saying that will message should be retained, that is what you are saying, because you have a will header and you have also a will message which will be served out. Whereas here this is about data, if the retain flag is set to 1, the publish packet sent by the client to the server must store the application message and its quality of service, and it can be delivered to future subscribers whose subscriptions match this topic. When a new subscription is established, the last retained message, if any, on each matching topic must be sent to the subscriber and so on. So, it is all mentioned quite clearly, right. So, folks, that is all I wanted to tell you about the protocol. I am just flipping through this protocol in detail because I think you should spend time understanding, reading and interpreting this in great detail. So, please spend time and get to practice a little bit with the ThingSpeak as well. Thank you very much.